The area of parallelograms, triangles, and trapezoids. We're going to start by looking at parallelograms. And within a parallelogram, which is this figure here, opposite sides are parallel and congruent. So you can see these symbols indicate that the opposite sides are parallel. And for congruent, we can make little tick marks. And the number of tick marks you can match to the opposite sides, that would be congruent. So if we analyze what a parallelogram looks like, before I talk about the area and perimeter, a parallelogram has slanted sides. However, if you were to cut off one side and you were to drag it to the other side, you would end up creating a rectangle. So a parallelogram has the same area formula as a rectangle because essentially you can rearrange the shape and you can get it back to the form of a rectangle. And you can see that in this model that I drew here. So if we come down to the area of a rectangle, which is something you all should know, the area is equal to the base times the height. And the area of a parallelogram is exactly the same. Area is equal to base times height. Now, one difference for finding the area of a parallelogram is that you actually need to find this height right here. You're not looking for the slant height, you're looking for the actual height, which might require you to do a little bit of solving in order to find that value. And one helpful thing when you're solving, or one helpful piece that we've been using all year, is the Pythagorean theorem. So using the Pythagorean theorem to help you solve for the height is going to be important. The Pythagorean theorem is leg squared plus leg squared is equal to the hypotenuse squared. So that's just, again, a helpful tip on something that you might need to use. And actually, in the first example, I believe we are actually going to need to use it. So, number 1 and 2, it says, given the parallelogram, calculate the perimeter and area of each. So as far as the area for number 1 goes, we can easily find the area. The area is equal to the base times the height. And we can see that the base is 30 feet, the height is 24 feet. So we can substitute those values in. And we can quickly determine that the area of this figure is 720 square feet. So that part's done. Now the perimeter, if you forgot how to find the perimeter is when you add up all sides of a figure. So when you're adding up all sides of this figure, I need you to add a piece of information I forgot to put in here. Oops, sorry about that. I need you to add that this is 7 feet. When you're adding up the perimeter of a figure, you need to have the slant height. So we need this height right here, which means we need to use the Pythagorean theorem with the triangle that I just highlighted in green. So we are going to solve for x in order to get that side, and if we find that side, we know the other side is also x. We're going to use the given value that I filled in of 7 squared plus 24 squared is equal to x squared. 7 squared plus 24 squared, when I type that into my calculator, is 625 is equal to x squared. Square root both sides, x is equal to 25. Okay, so knowing that x is equal to 25, we can now start to solve for the perimeter. The perimeter is when you add up your sides. So we have 30, this side is 25. This entire side is 30, because remember its opposite sides are parallel and congruent. And this side is 25. So you can either add each individual side, or we can do 30 times 2, because there's 2 sides at 30, plus 25 times 2. When we add the perimeter together, our final answer is 110 feet. Remember, perimeter is length, so it is just feet. It is not feet squared. This here is your final answer. For number two is actually going to require you to use the Pythagorean theorem in order to find the height of this figure. So I'm going to label this as x, and we are going to solve x squared plus 8 squared is equal to 17 squared. When I type this into my calculator, I have x squared, 17 squared minus 8 squared is 225. Square root both sides, x is equal to 15. Okay, knowing that x is equal to 15, I can now find the area. The area is equal to base times height. The base is 21. I know it's at the top, but recall that the top and the bottom are equal. So 21 times 15 is going to give us the area, which multiplies out to 315 square centimeters. The perimeter is when you add all sides. So we have two side lengths at 21, and we have two side lengths at 17. When we multiply these and add them together, our perimeter is equal to 76 centimeters. And that is our final answer. Okay, I want you to take a moment and complete the on your own section by yourself. You can come back to the video and check your answers against mine. Moving on to our review of special right triangles, because we're going to be using these as well. I'm not going to spend much time going over them. I'm just going to read you what they are. So for our review, we know that we have 45, 45, 90 triangles. And within a 45, 45, 90, we know that the formula states the hypotenuse is equal to the leg times the square root of 2. Also recall that your two leg lengths are the same length, and your hypotenuse is used or solved by using that formula. Besides from a 45, 45, 90, we have a 30, 60, 90 triangle. 30, 60, 90 triangle has a short leg, a long leg, and a hypotenuse. The formula for the hypotenuse is 2 times the short leg. Longer leg is equal to the short leg times the square root of 3. So you might have to use these triangles to answer parts of the next problem. Number 1. We are given the parallelogram. We're only asked to calculate the area for this figure. So within this figure, I can see that I'm missing the height. I can also see that I have a 45, 45, 90 triangle. If I have one 45-degree angle, that means the other one is 45 degrees, and I of course have my right angle. So I'm going to work with my 45, 45, 90 formula. And I know that this formula states the hypotenuse is equal to the leg times the square root of 2. I know my hypotenuse is 8.5. My leg length is represented with the variable h times the square root of 2. I'm going to divide by the square root of 2. However, when I divide by the square root of 2, I eliminate it on the right. On the left side, I'm going to have to rationalize. Hopefully you remember doing this from earlier in the year. This gives me a value of 8.5 times the square root of 2 over what would be the square root of 4, and that simplifies to 2. This is your h value. So now that we have our h value, we can solve for the area of this figure. And the area of this figure is going to be found by the base, which is 15, times the height, which is what we just found at 8.5 times the square root of 2 over 2. And I'm going to type this into my calculator. Be very careful when you do, because you need to make sure you have parentheses around the appropriate expressions. But when I type this in, my area is approximately 90.16 square feet. And you should all try this. Make sure you get the same answer as me. That way you know that you typed it into your calculator the correct way. For number two, we're looking for the height again. So we are missing this height here, but we can see that we have a 30, 60, 90 triangle. So having a 30, 60, 90 triangle allows us to use the formula, and we're looking to specifically find the the long leg here. This is the longer leg. We don't need to find the hypotenuse. We have the length of the short leg. Remember, the short leg is always directly across from the smallest angle, which is 30. So I can use the formula that says the long leg is equal to the short leg times the square root of 3. Long leg is represented with h, short leg is 12 times the square root of 3. And that right there is the height of your parallelogram. So once we find the height of the parallelogram, we can use the area formula, which is the base of 32 times the height that we just found of 12 times the square root of 3. When I substitute this into my calculator, I get approximately 665.11 square meters. Next, we're looking at the area of a triangle. And this is also something you've done in the past. So you might remember the formula, which is area equals 1/2 times the base times the height. Now, it does not matter what the triangle looks like. It could look like number 1 here. It can look like number 2 here. No matter what, this is the formula for the area of a triangle. So if we work on number 1, we are finding the area and perimeter of each of these figures. So number 1, we can certainly find the area pretty quick because we know that we're looking at just the shaded region. Let me highlight that. So in number 1, we know that we can multiply 1/2 times the base of that shaded region, which is 19, times the overall height of this, which is 30. Make sure you get the correct height, not the slant height, the actual height. So the perpendicular height from the base to the top. So 30 is your height. Type this into the calculator. We get 285 square inches. Now, calculating the perimeter is a little bit more challenging because we need all of the sides of the triangle. So you can see we have 41, we have 19. We're missing this side that I just added the variable x in. Well, we have additional information here, and it looks like we have additional information for a second triangle, of which we could solve for the hypotenuse using the Pythagorean theorem. So we have 27 squared plus 30 squared equals x squared. 1629 is equal to x squared. Square root both sides, and x is approximately 40.36. So when I calculate the perimeter, I add up just the sides of my shaded region, and I have the side length of 19, the side length of 41, and the side length that we just found of x, which is 40.36. This tells me that the perimeter is a rounded number, so it's approximately 100.36 inches. And that's the perimeter of your figure, or the triangle. Now I want you to try number 2 by yourself. It's very similar to number 1. I know the triangle is a slightly different shape, but you are still finding the area and perimeter of the shaded figure. So press pause in your video, try this by yourself, come back together and see if you get the same answer as me. So when I find the area, I end up with 167.19 square centimeters, and you can look over my work here if you did not get the same answer as me. And for the perimeter, I end up with 71.74. Okay, next up is trapezoids. So trapezoids is kind of a interesting topic. We haven't done much with trapezoids this year. So I made some notes, and I'm just going to read through them with you. You can copy them down if you need to, or maybe you feel like you already know what a trapezoid is. So within a trapezoid, you have two bases. We have base 1, we have base 2. Does not matter which one you label as 1 or 2, but you have two bases. You also have the height. The height is the perpendicular distance between the bases, so similar to a triangle. The height might be given outside of the figure, but it is the distance between base 1 and base 2. So the area of a trapezoid is given by 1/2 times the height multiplied by base 1 plus base 2. So you have to add those values together. Now, if you want to take a moment and look through my notes right here, please do so. I, for the sake of time on this video, am going to skip down. This is just a little bit of background info as to where the formula comes from. But we can certainly skip down to the examples, and if you have time, you can come back to this explanation. All right, so looking for the area of a trapezoid. Because this one is new to us and we haven't done it yet, I'm just going to write it right at the top of our page. So the area is equal to 1/2 times the height multiplied by base 1 plus base 2. And for number 1, we have all of the information we need. We have base 1, we have base 2. And I'm just going to label them. It doesn't really matter which one you pick, but I'm going to say base 1 is on the top, base 2 is on the bottom. When I substitute these values into the equation, I have 1/2 times the height, I could write that out, times the height, which is 30, times base 1 of 28, plus base 2 of 58. Type this into my calculator, and I have 1,290 square centimeters as my answer. And once again, you should practice making sure you get the same answer as me. Make sure you know how to type that into your calculator. Number 2, I'm going to label 85 as base 1. I'm going to label 72 as base 2. Our area formula states that I can write it as 1/2 times the height of 38 times base 1 of 85 plus base 2 of 72. When I type this in, 2,983 square inches is my answer. And for the last section on the notes before the on your own section, this is working backwards. So it says, given the area, determine the value of x. Looking at number 1, this is a parallelogram. So a parallelogram uses the formula of area equals base times height. And we need to fill in everything we know. So we actually know the area, it's given to us. So I'm going to substitute 148 into the equation for the area. I know that the base is 8 meters, and I'm looking for the value of the height, which is represented with variable x. I'm going to divide both sides by 8, and this gives me my solution of 18.5. And that is how you work backwards in order to find the height. You substitute in what you know, and you solve however you can do it. Number 2 is a triangle. So number 2 is going to use the equation of area equals 1/2 times base times height. We are given the area of 357. So 357 is equal to 1/2 times the base of 34 times the height of x. So I'm going to write this out as 357. 1/2 times 34 is 17 times x. Then I can divide both sides by 17. And x is equal to 21 inches. To finish off the note sheet, there's 2 of these problems that I want you to complete by yourself. So again, pause your video, come back together, and you can check your answer against mine.